Yeah, so maybe to give you some background, yeah, maybe everyone can just quickly introduce themselves and yeah, let's do the round. Yeah, we're not that many. We're not that many people, so yeah, that's not a problem. So.
Do I want to start? My name is Dawid Wysakowicz. I'm a Flink committer. Recently, for the past year, I'm involved in the work around SQL and pretty much all the stuff that Timo described in his presentation, and that's pretty much about me.
My name is Kurt, and I work at Alibaba. I also a Flink committer and also a PMC member of it. I'm mainly focused on the Blink Planner, which I introduced by Timo last talk. Yeah.
Hi, my name is Bowen Lee. I'm a Flink committer and a senior engineer at Alibaba. I think we are having like really a VIP session. Yeah. You will first time have like the equal number of user with equal number of supporters. Yeah, glad to have this session and looking forward to answer any questions that you have.
Oh yeah, you can use this back. Oh. So we continue with the introduction round. And, okay, so my name is Theo Dieventhal. I'm a software developer for a small company. I'm currently developing for Deutsche Telekom on a big data project running on Cloudera clusters, and we're using a lot of Flink, but very low level, and I was investigating using more high-level Flink SQL for running our fraud detection queries, or some of them, recently. So I just thought I'd join the discussion and see what features I could get out of Flink SQL.
Thank you. So my name is Cyrine Forgewi. I work as an R&D engineer for a Belgian company called Euronova, and we are based in Marseille and Tunisia. So I work from Tunisia, and we use Flink a lot on our current product and for our clients. So I'm interested to know what are the SQL features that we were gonna talk about. Thank you.
Okay, my name is Alexis Jean-Renaud. I'm team leader in a cloud provider in Europe called OVH, and I'm in charge of the big data products, and namely our Flink support in the cloud. So that's the reason of my presence in Flink Forward. And we also use a lot Flink in our internal pipelines for the KPIs of all the companies. So I really want to know more about the SQL features that will be shipped with Flink, and especially if that's something like the big thing, meaning that the data stream API maybe will move to a full SQL-based API or not, to know where our customer could go with Flink afterward.
Hi, I'm Alyosha. I'm a software engineer at Viverica. I have the same T-shirt. You can see that. I'm a Flink committer, Flink PMC member, working on different things.
Okay, so I'm also a software engineer at Viverica. I'm also a PMC member, also a committer. I focused on SQL, or better to say, like I focused on the table API in the very early days. So I think it was in 2015, I think, end of 2015 or something, where there was no SQL API yet, just a very, like a skeleton of a table API. And then, like together with other colleagues and the community, we started this whole SQL effort and the entire SQL journey. Yeah, I developed at different components of SQL. Yeah, that's from my side. Okay, so yeah, how do we start now? Yeah, maybe we just discuss some of your questions first, and I also have a couple of questions that we can also discuss. Yeah, so who has questions?
Oh, by the way, I work on Hive integration mainly. So if you have anything related.
think Gary had a question, for example. Okay. Yeah. Just raise your hands and then.
Yeah. If you can give us more insight on what it means to integrate Hive into Flink.
So your question is what the Hive integration actually is about, right? So I think for Hive itself, we have integration with Hive's metadata and Hive's data. So the data part is easier to understand, right? So you have data managed by Hive, like Hive tables or managed tables or external tables or views. So Flink will be able to read and write all this data. On the metadata part, I think there's two perspectives. The first one is, I usually call it like round trip. So Flink and Hive can both understand each other. Basically, anything you already have in Hive, like the tables, views, functions, all these meta objects, Flink should be able to leverage that. And Flink is also able to create such Hive objects. Like you can actually replace your Hive client with Flink client and say, hey, I want to create a Hive table. And that way Hive is also be able to understand it. So you achieve this by-way like interoperability. The second part is, so if you use Flink, use SQL before, then you know like currently its metadata is not persisted anywhere, right? So you every time if you want to have this query, you would write like a multi-line create table, and then you would say like select from and other like SQL queries, right? So it's not very convenient. The second part is we are storing this non-Hive meta objects in Hive metastore, and by using the metastore purely as a storage. So you say, hey, I want to create a Kafka table. I just want to create it once and reuse it in my later queries. Then we just persist that Kafka table into Hive metastore. And Hive actually won't be able to understand it, right? So this is kind of the core part. And of course, in order to achieve that, we need to fill in all the gaps to achieve that initiative. For example, we added catalog APIs. We redefined lots of like the function, SQL function stack. So the first like integration is like really core to just integrate with Hive, and you can see another surrounding pieces that connect that act as a bridge between the integration and the Flink's I would say SQL stack, like catalog APIs, for example. Yeah, did that answer your question?
Yeah, absolutely.
Yeah, okay.
And generate a new one. Does it mean that in the future I will be able to like create a table in Hive, which is actually inside Flink, maybe to create the states or that kind of thing?
Yes. So you create you were saying like you create a table in Hive, and right, and then you query it in Flink.
No. I create a table, and the actual location is inside Flink, just like I can do that with an external.
Oh, right, you know. right. You create a Hive table in Flink.
Yeah.
You'll be able to do that. I think the missing part right now is mainly just DDL, right? So we are kind of finalizing that. Then you will be able to do that through SQL client. But right now you can already do it through table API. But it's just a little bit like more programming.
But was the question about storing the data in Flink or using Flink to create the table in some catalog and then using Hive to read that catalog?
The question was, actually, the idea is that today we have the ingestion pipeline with the live data,
Yeah.
and more like at rest data that is provided to our BI tools. And the question is, are we able with that work to make joins between the live data and the at rest data inside the same tool?
So you have live data coming in from Flink, right? And this pipeline, you want to join it with some historical data in Hive.
Yeah, and directly from the BI tools, just like Power BI, Tableau, or all that kind of stuff.
Yeah, I think you'll be able to do that because we provide Hive source out of shelf. So in that case, it would just be a join, SQL join, right? You create, you have this Hive table, you have its metadata in a catalog, and you would just, for example, join a Kafka stream with some Hive data.
Some addition, and it's actually, if you think this deeper, and it's actually a very interesting scenario. It's not a purely batch scenario like two static table joined together, and it's also not the same streaming join, regular streaming join. For like a regular streaming join, each of the inputs will trigger the computation, right? If the left side comes one data, you might generate an output, and if the like a static table, maybe it change a bit, so there may be some input coming. You will also trigger the computation. It's a regular streaming join, but in your case, it's like you only want the streaming side, like to trigger the computation, right? The static one is just be like the waiting for read and enrich the mainstream. It's actually a feature we provided in Blink Planner. We call it a temporal table join. It's very interesting scenario. Like we are treat every table as a temporal table. It's like it's actually happened next door. Is Fabian will describe this like one SQL to rule them all. It's treating every relation as time version of relation, and when it also exposes ability to access the a version of that table, because the table is changing, and every time it changes, it will change the version. So if we have this ability, and we can write the SQL differently than the regular join, like we use a join. It's hard to describe. It looks like the regular join, but we will introduce some new SQL keyword code for system time as of a point of time. It's like it's semantically different with either batch join or streaming join. It's I think I don't explain clearly without an example. Maybe you can come to listen to Blink Planner tomorrow, and I have a detailed explanation.
Yeah, like in general, like whenever people are asking, hey, how can I enrich my stream? How can I join my live streaming data that comes in with some static table? Actually, when you really think about it, there is no static table. Like every pipeline, at some point in time, you also need to update the static table. So whenever you're joining a record that comes in via through the stream side, you always have... Something's going on. Okay, you always. Actually, what you want to do is, as Kurt said, you want to access the table, the static table, but it's just static at a certain point in time. And that's, yeah, like this concept of temporal table helps here. Like that's also why the SQL standard added this. So you can parameterize your table, and you give a time. Usually it is the row time that comes, like that is encoded in the event, and that you're just passing this row time to the table so that you can view the entire table at this point in time. But we need some more optimizations around this whole topic, and how can we actually also produce reproducible results, because I think also like this temporal table join is mostly working on processing time right now, right? Yeah, so we also need to investigate actually how can we do the same computation again with exactly the same results? Because working on processing time means there is no reproducibility. Yeah, it's just, the result could be different every time you're executing the query.
Maybe a good example of where this is important is if you think about a financial use case where you have, say, some stream of currency exchange rates and you have a stream of transactions that are coming in. And if you, I think that's the main or one of the motivating cases for temporal table joins. If you see a transaction that has a timestamp that says when the transaction happens, and then you want to connect that or look up the currency conversion rate in the currency lookup table, that is the last currency exchange rate for that timestamp, but it is not a timestamp from the future. So it's a weird query that is hard to express in SQL because of this highest timestamp that we have seen, but not higher than what the timestamp of the currency is, because that would be a currency exchange rate from the future. Because in these distributed systems, it can happen that or if you do reprocessing of older data, it can happen that there is a newer currency rate available, but you see a transaction that maybe is delayed by an hour from some external system. That's where these temporal joins are important, I think.
But if they work in processing time, it could also happen that they are built on an old message and didn't receive a newer run, right?
It's arbitrary. That's why we have something in Flink already that was present before the Blink planner was merged. It's called also temporal table join, but with temporal table functions. And those temporal table functions, they're very similar to what Kurt said, but they are consuming a change log of data. So they are basically, they have access to the entire change log of the table. So like if we have a currency table, okay, the euro was at this currency at 11 o'clock, at 12 o'clock, at 30 o'clock, and so on. So we are keeping all the currencies in state that are needed to join still potentially arriving data in the other table. So we have some concept there, but that is not batch processing. That is more stream processing. And the question is, how can we improve that for being more performant also for batch processing? Or like, how can we optimize the whole thing? I think that is still unsolved.
Joining the binary logs of the databases.
Yes, yes. I think with some tooling around, it's already possible because like internally within in the lower stack, the table and SQL API, they already work with a change log. So there are insertions and deletions traveling in the stack. But we also want to expose that actually very soon. So we are already discussing how can we further develop the DDL so that you can also define a change log, like the format of a CDC log that comes right out of the database. Yeah, that is on the roadmap. Yeah.
Just one thing. I think it's important to think about from the user perspective that, like from what the guys already described, that there are actually two, let's say, the approaches on the execution part. How do you do the temporal join? You can either that's what Blink did in 1.9, if I understand that correctly, so that you have the temporal join, which basically performs a lookup to external system, and then it depends on the external system how it stores. Like you might not have access to the CDC there, and this is a bit harder if you want to have very reproducible examples, because you might not have the access to the historic data, because like the row might have been just updated and you don't have the history. With the Flink approach before pre 1.9, it was that we streamed the whole CDC to inside Flink, but then we have to maintain the changelog internally, like, or the version table internally in Flink, and like we have the burden of keeping the table in memory. So like even if we can solve that from the semantic perspective, there's still some like problems from the user perspective. How actually how the data that we own actually looks like, and in what format, and in what, how it is updated.
some other questions?
As far as I understand, it will be available with the new version of Hive and not the previous ones. Just asking because in our pipeline, we use ORC for file format at the end of the pipeline in order to write the ingest, and the pipeline is we read the binary logs of the data sources, stream it to Flink, map it to a common format, and write it to ORC format at the end in order to query it through Hive. And we had the problem with the metadata from Hive, so we passed through several phases, and we figured out that it will be available with the Hive 3, but will it be backported to the older versions of Hive or not?
Let me try to
Sorry.
repeat your question. So you have this pipeline that is writing ORC into Hive 3?
No, into Hive 2.
Oh, Hive 2, okay. And what's your question?
If I get it right, the Hive integration makes Flink compatible with the Hive metastore thing. That means that if I write in Hive, the metadata is correctly updated, and I can query it through Hive directly. But with our current pipeline, it's not possible because the ORC version of Hive 2 is not compatible with the one that we were using in Flink.
Oh, yeah, I see what you mean. Yeah, right. You're absolutely right. So the Hive ORC is kind of incompatible with Flink's ORC in the Flink formats module. So the ORC version that we use will be the version that has that is located in your Hive deployment. So yeah, with our Hive sync, then you will be able to just write into the ORC version that you want, and then have the BI tools in Hive to query it. Does that answer your question?
So that means it will be by design backported to the version of Hive that we are using.
Sorry, can you say that again?
That means that if the version of Hive is supported by the integration of the new Flink, we won't have to make a step between the Flink write and the Hive query.
Yeah. So I think just two things come into my mind, right? The first is the Hive versions. So in 1.9, we only officially support 2 versions, and relies on Hive's own compatibility for other versions. But 1.9, we are supporting lots of versions, I think all the minor versions of 1.2, 2.x, and 3.1. The other thing is right now in 1.9, the Hive sync is only, I think, batch only. So in 1.10, we're trying to make it a streaming sync. So that means you can actually having a streaming source, reading from the streaming source and write to Hive directly in 1.10. Does that answer your question?
Yeah, okay. I think so.
Yeah, and thanks for supporting our feature. And if you have any user requirements or any feedbacks, you can talk to me or email me or directly discuss it in the user or dev mailing list.
With pleasure. Yeah.
Yeah.
And maybe the just near question would be: will you support a SQL query on top of object storage or that kind of stuff, like S3, or if can we extend the Flink joins on external things that are not really related to Flink or Hive, like pure databases like PostgreSQL or anything else, or object storage?
I think they may have some ideas. I'll just share my 2 cents here. I think, yeah, definitely can do that. I think maybe some missing part is just we need to have, do we have like a table connector or S3 and other connector? We need a table format, right?
I think as far as I know, but Alyosha can correct me. But I think like for writing out, I think we have like streaming file syncs that writes to S3 and so on. For reading, I'm not quite sure, but in general, it's just like, yeah, we just need to develop more connectors. Like this is in general the problem. It's not a new problem that we have a very good core. We have a lot of operators, but this whole ecosystem, like having more connectors, we need to improve there. But it's also one of the most toughest ones because there are just so many systems out there. But like from the architecture perspective, it doesn't matter if the data comes from a database. So if you just want to read the entire table as a batch, this is possible. If we want to connect if we want to connect to the database in a continuously fashion, that is a bit more difficult because databases were not meant for streaming. So here you need to access the CDC log maybe. But in general, like just reading batches of whatever, ORC files, S3 buckets or whatever, I think that is, from an architectural point of view, that it should be possible. Yeah.
So if there's a file sync, and you have a format for the format that you want to read, then that should work. I mean, because Flink has this file system abstraction, and S3 can look like a Hadoop file system, and then it can read that.
You mean if that's arrow-based? Schema describe the data should be easier to read?
Maybe. I'm not sure about the formats, but I think we have an arrow read format for the table API, don't we?
I think, yeah, I think we have an input format, but I'm not sure if it's like is it support, like, do we support S3? I mean, you have also developed the input format recently, right? Like for Blink.
From my understanding, there are actually two things, independent two things. One is what's the file system, the file you stored, and the other one is what's the format of your files. And currently there is an ongoing effort. Like we want to support the partition table, and the design document said it will introduce a new connector. We call it maybe call it a file system connector, which can do this, which can combine these two things together. You can in this connector you can choose whatever file system we already support. We actually support HDFS and also S3. I think we also have a S3 file system. So it actually happens very easily. When you type the path of the files, you have some prefix, right? HDFS / or S3 //. And actually Flink can recognize it and will load the file system module automatically. And also we will have some format description about the files, whether it's on Avro format or on ORC format. You can set these two properties independently for in this connector, and we are able to read it. It can, all these are combined into one connector.
Any other questions? Maybe from the other folks? Yeah.
Can you share a bit about your roadmap? How you what you're gonna go to do next, or especially for the connector? When do you think you can release this?
I mean, it depends on it really depends on the team. We are also different teams. Like, for example, Dawid and I, we are from the SDK team, so we are very concerned about general, how does the API look like, which primitives like catalog interfaces and so on we are exposing to users that also want to extend our system. So our main goal right now is really, I also talked about that in my presentation. that we need to make the API stable. So because in the past, the API was mostly designed just as people thought SQL is like, but nobody really looked into the SQL standard. Nobody really looked deeply how do other vendors are doing it. Yeah, so because like we need to do some API refactoring that is on our roadmap right now. Like we need to come up with a clear definition. What is a temporary function? What is a system function? How is the namespace and lookup resolution and so on of all these functions? This is from our side. And then comes more the runtime side, but I think Kurt can say more about that.
Yeah, from my side, if the API is getting more stable, actually I was mostly focused on making the SQL like a performance very well, and functionality, more functionalities, and you can run any streaming SQL job very efficiently, as well as the batch SQL jobs. Also, we have some mixed execution mode, like the scenario we just described. One side is streaming, another one is a batch. Like we want to support all kinds of computation scenarios and make it efficient and fast and stable. So back to the connector, I think it's we have a good chance to make it happen in 1.10 release. I think as the community's release plan, we might have or still have 1 month and a half. I think it's maybe a doable feature, from my opinion.
In general, I think like we also rely on the community for providing connectors, because like you can really, I mean, developing a connector is one thing, but really testing it in production with a lot of data, with yeah, like in production, that's not what we can do all the time for every system, because I mean the systems also upgrade their versions, and then we need to make sure that we're still compatible with this system and so on. That's why we also rely on bigger contributions, also from bigger companies like Uber and so on. Like I remember that Uber, for example, they contributed a Parquet input format recently. Yeah, so like this connector world, it's very hard to plan it on a roadmap. Like the Hive integration, that was really planned because that is very important. And Kafka is still one of our main connectors, because everyone is using Kafka as a storage system or log system in the companies, and everything else is just yeah, on demand basically.
As for the connectors, some time ago there was an initiative started to come up with a like Flink ecosystem webpage where we would help people to advertise their connectors, so that because like we are not able to maintain all the connectors, so we really try hard to help people just to provide their own connectors and make them visible to the community, to the users. What we really try as the core developers to provide the best abstraction, so that providing a connector becomes very easy, and we really hope for some other members of the community to provide, and which is like harder to maintain the connectors, because like we unfortunately cannot do that for every single external system there is around. So yeah, one thing, it's unfortunately it's not available yet, the Flink ecosystem, but it's developed, it's ready to be published. Unfortunately, we are like facing some legal issues with this, but this should be solved anytime soon.
There's also an iceberg talk later today. Someone mentioned iceberg.
Yeah, I think like a lot of like in general, this connector topic is not only a Flink-related topic. I don't know if you have heard of Apache Here, for example. That was an Apache project. Basically, it should just dump the connectors from the main source repository to some other repository so let the Apache Bahir community deal with it. That's what Flink did at some point, and Spark did the same thing. But I don't know how healthy the Bahir community is, but we also noticed that is also not the solution. So now we are coming up with a more community-driven website or something where people can rate and comment and maintain connectors. Maybe that helps in the future to solve this problem. Are we running out of time? Okay. So thanks for also this little audience, but at least we filled the time with some good content, I would say, and hopefully we could also answer some of your questions.
Okay, also from my side, thanks everyone for attending this panel discussion here and for the fruitful discussion. Yeah, right. So unfortunately, we ran out of time, as Timo already said. I'm pretty sure the committers here in the panel are available for your questions also after the session here, and you can approach them if you have any questions. A quick announcement from my side, there's a coffee break now, and there's a book signing happening upstairs at the Wysakowicz booth. So you have a chance to get a free signed copy of the book, Stream Processing with Apache Flink. The authors will be there. Possibly free, if you're fast enough. So there's a limited number of books, so be quick. Okay, that's it.